All right, juniors, you just left. Seniors too, I guess. Is there any seniors in here? Okay, so this is just juniors for the first period class. You guys just left. We're finishing the notes here. I'm gonna try my hardest to use this compass underneath of my thing so you can see what's going on here. We are copying the following segments, JK. So basically, I want to know the length of him, right? How can I use this little protractor thing to determine the length? Put it on both ends. Okay, now, I'm going to make life a little bit easier, and I'm going to do this down below here. I'm going to go ahead and put a dot down here, and we're going to call him J, but we can't just call him J. What can we call him instead? He's not the first J. He's not the original. He's like the remix. He is J prime. He has a little dash above him. That means the copy of J, he is like J, but he's not the original J. He's the remix of J. And so he is J prime. That little dash means prime, okay? So what I'm going to do is I'm going to measure this guy. I'm going to put my metal tip on J, and I'm going to put my pencil tip on K, and I'm going to measure how wide he is, and I'm going to try to get as close as I can. There he is, okay? And then I take my protractor, my compass, not protractor, and I put my metal tip on J, right here like this, and then I mark him. I put a little dash through him. You see how that works? Yes, yes. And then I take my pen, and wherever he intersects that line, I put a K, but we can't call him K. He's the remix of K. We call him K prime. There you go, K prime. Okay, we're going to do the same thing for AB. So put a little mark on A where he is. We're going to make a little dot, and we're going to call him A prime. And then we're going to measure AB. We're going to dash him. We're going to do all that good stuff. AB is really tiny. He's kind of hard to do. I might have to adjust my pencil tip here. Push him in a little bit. I don't know. Maybe not. Okay. AB. Here we go. A to B. A to B. A little bit bigger. Are you getting yours over there? You folks? You're doing this a little bit better than I am because I'm trying to put this underneath my dot trim. Okay. So there's A where he intersects. And I'm going to make my dot. There we go. There we go. I could make a circle all the way around if I wanted to. But there's that. Okay? Don't have to make him quite so wide. There's A, B. I can copy that segment. B prime. There he is. Okay? Does that make sense? You can use this guy to notch off, and this is like a measuring tool. These things are awesome. They used to use these like crazy in like Egyptian times. They didn't look as high tech as these guys did. But they had these, and that's how they would like measure. Like sundials are kind of the same type of tool. They're basically based off of measurements, right? You know what a sundial is? Yeah. Well, except it lays down flat. It's like a rock. It's a shadow thing. Yeah. It's like basically a clock. It's based on the sun. Anyway, whatever. Whatever. So there's that. So there's the measuring tool. We're going to use this to do a lot more cool stuff, like making angles. Maybe I'll show you that at the end. Since all the dumb juniors are gone. Oh, wait, I'm recording. I'll show you how to do some cool things at the end of this lesson here. Okay? So, anyway, all right, example 4, distance and midpoint. Oh, my goodness. Oh, my goodness. This is a formula that you will have memorized. Mark my words. You will have this memorized. This distance formula. Memorize it, learn it, do whatever so that you can know the distance formula. But I'll show you how this formula works, and then you'll have it figured out. All right? Oh, that's the quadratic formula. The roll under the negative b plus or minus. I don't have a song for this one. Sorry. All right. Find the distance of BE. Okay, this is just a number line. This is not dealing with coordinate points. This is just a number line. So B to E. B is at -6. E is at 2. How many units are between them?
8.
8. Okay, here's what you can do. Rather than counting, you can do this. You can do 2 minus a -6. You're always subtracting between like distances, right? 2 minus a -6, which would be 2 plus 6, or 8, because B is a -6, right? 2 minus a -6, yeah? So that's 8 units. But suppose I did it the other way around. -6 minus 2. That's -8, right? Can you have a negative distance, though?
No.
You can have negative points, so it would be like taking the absolute value of both of these, right? So there's 8, and there's 8. Does that make sense? So whichever way you want to subtract them, you can do that, and you don't have to count, but then make sure you take the absolute value, because distance is only positive, right? Determine whether CA and ED are congruent. What does it mean to be congruent?
The same.
Same, like basically same shape, same size. So I'm just going to put same size down because we're not really talking about a shape here. So same size, CA. Let's figure out what CA is. C to A. Let's do -7 minus -4. Those are the points from C to A, or A to C, whichever one. That gives me a -3, but we know it has to be absolute value, so that is a distance of 3. Yeah? Does that make sense? Okay, CA, and then ED. E and D. They look like they're pretty close. E and D. Let's go 2 minus a -2. Again, it doesn't matter how you subtract them, but just make sure you turn them to absolute values. So that's 2 plus 2, which is 4. Absolute value of 4 is 4, right? You wouldn't necessarily have to take the absolute value of 4 because it's already 4, but if you get a negative, make sure you change it to a positive, okay? Are those two things congruent? Are they the same size?
No.
No, not congruent. Not congruent. You guys are in geometry this year, right? You guys will learn the symbol for congruent is an equal sign with a little line over top of it. I think maybe I talked about that in chapter 0. Okay? Not congruent. Congruent is equal with a line over top of it. We'll use that shortcut all the time. Not congruent. 3 and 4, those are the distances. That's bad. Okay? Now, this was if those two things are all on a number line. Okay? We could find the distance between them. That makes it really nice. But what happens if they're out in space in like two-dimensional land where you have an X and a Y coordinate, like this guy and this guy, right? We have the formula, right? Okay, so let me just show you kind of what this means. Okay, let's talk about C and D. I'm going to mark this off over here. If you don't want to write this down, you don't necessarily have to. But -4, 1, 2, 3, 4, -6. I'm just going to show you once how this all works, all right? And then 5, 1, 2, 3, 4, 5, -1. Okay, and I'm going to draw my line in between them. Okay, what I'm trying to do is I'm trying to find the distance of that thing, right? Okay, and the formula is going to tell me how to do that, but here's where the formula comes from, because it makes it easier to remember the formula if you can remember where he comes from and what he means, okay? So let's say I take this guy and I make him into a right triangle. I could draw him up the other direction. I could draw him this way, right? Okay, but I'm going to draw him down this way, and I'm going to make him into a right triangle, okay? Now, how can I find this length, the purple length, of that right triangle?
Slow.
Kind of. I'm wanting to find how I find the distance of this purple line. If it's a right triangle, we can use what? A squared plus B squared equals C squared. You're right. But I have to know this length down here at the bottom, right? This length down here at the bottom, okay? So let's figure out what this bottom length is, okay? This is -4 minus 5, which is -9, but we always do the absolute value, so this is a +9, right? Down here on the bottom, this is a +9. Okay, I found that distance, yeah? Okay, now this one on the side here, this is at, what, -6, -1, so -6 minus a -1, or -6 plus 1, which is -5, but we need absolute value, so he is +5, right? He is a +5, okay? Now, 9 and 5 are the two sides of my right triangle, and I want to find the third side, so this is very, very easy. I just take 9 squared plus 5 squared, and that's what C squared is, right? Okay, 9 squared is 81. Ooh, I'm going to run out of room. Plus 5 squared is 25, and that's what C squared is. Okay, 81 plus 25 is what? 106. 106 is what c squared is, but then I have to take the square root. Is it what? 10.29? Sorry, I didn't hear if it was 9 or 10.29. 10.29 is what the square root of 106 is. Okay? So let's look at this in comparison to the distance formula. We use the Pythagorean theorem to find the distance. The distance formula is based off the Pythagorean theorem. Based from Pythagorean theorem. Okay? Where this guy is my c squared, this guy is my a squared, and this guy is my b squared. Okay? So just look at this part right here. x2 minus x1 squared. The x2 minus x1 was these guys, negative 4 minus 5, right? And we got 9, and then we squared the 9 to get a squared. Yeah? Does that make sense? Okay? The b was the distance between the y's, which we determined was 5 after we took negative 6 plus 1. So this is my b squared. But then why in the formula do they just have d and not d squared? Yeah, they went ahead and they altered this formula so that the square root is already there. So rather than c squared equals a squared plus b squared, they write it as c equals the square root of a squared plus b squared. Does that make sense? Yeah? So they just altered it a little bit, all right? But to find a and b, we did kind of what we did up here, where we're just subtracting the coordinates, right? And then squaring them, all right? So let's come down here, let's do part b, but let's do it with the formula rather than mapping it out, okay? So b, we have these two set of points, right? And to find the distance, we want to take the square root of the x coordinates subtracted, the y coordinates subtracted and squared. This is what your distance formula is going to look like every single time. I always set it up like this, and then I just plop the numbers in, okay? So the formula says x2 minus x1. Which one is your second x coordinate? No. Okay, so this is an x, this is a y, this is an x, this is a y. Which one do you want your second one to be? Negative 3 is your second one. So these are your 2's and these are your 1's. Okay, so if it helps you to write it out, you can sure do that. Some of you guys probably don't have to write them out. So x2 minus x1 would be like negative 3 minus 2, yeah? Okay? And then my y2 minus y1 would go here. Negative 2 minus 4, yeah? Okay? Negative 3 minus 2 is negative 5, and negative 2 minus 4 is negative 6. Okay, now, remember this, you people who are watching the video, if you don't get anything out of this distance formula, remember this is the absolute most important part. And somebody's still going to screw it up. Don't be that person. When you are taking these numbers that are inside parentheses squared, negative 5 squared, what does that give you? Positive 25. Okay? I have so many people who try to put this into their calculator and they write in negative 5 squared. Well, if you type in negative 5 squared into your calculator and don't put the parentheses around it, it will automatically put it as a negative 25. And then they'll get the answer wrong. Right? It's always positive when you square this guy. So you might as well just even call this a positive 5 rather than a negative 5. Don't ever think of that in terms of negative. It's only ever going to be positive after you square it. So this is going to be the square root of 25 plus 36, which is the square root of 61, which is some big long decimal, I think. Something like that. What's the square root of 61? Not quite 8, 7 point something. 7.81? Because 8 squared is 64, so 7.81 is pretty close to that, right? So do you see how that works? Now, you guys said, does it matter which one I count as my x1 and y1? Or an x2 and y2, okay? So let's say I went the other direction. You don't necessarily have to write this down, but I'm just going to show you, okay? So let's say instead of doing negative 3 minus, right? That's going to turn this guy to a positive. 2 plus 3 is a positive 5, right? Instead of a negative 5. But when you square both of them, they're going to turn to positive 25 anyway, right? This guy is positive 5, and 5 squared is the same thing as negative 5 in parentheses squared. So it doesn't matter which one you go first. Does that make sense? Okay, it's all going to turn out the same. All right, let's go to this one. Luke is standing on his team's 20-yard line. So this is where Luke is. He is at the point 20, 5. And Xavier catches it on the other team's 40-yard line, which is 20 yards from the same sideline. So he is at the point like 60, 20. How far did Luke throw the football? So they want the distance in between them. How far did Luke throw the football? Okay, so let's do some distance formula. Yeah. So you set it up like this, and you set it up like this. And we're going to plop our numbers in there. So do you want to call these the ones, x1, y1, x2, y2? Doesn't matter which one you use. I'm just going from start to finish, right? He's starting there and he's finishing there, so 1 and 2. Okay, x2 minus x1. So that would be 60 minus 20. Is that right? 60 minus 20. And then y2 minus y1 goes in here. 20 minus 5. 60 minus 20 is 40 squared. 20 minus 5 is 15 squared. Do you know what 40 squared is? 1600. Plus 15 squared is 225. 225. I get kind of lost after a little bit after that. So that is the square root of 1825. We're running close on time on the ACT. You guys haven't taken the ACT yet. A bunch of you probably. But most people who run out of time are running out of time on the ACT on the math part because they're using their calculator too much. I can do that, add those two together. I can add those two together in my head faster than a calculator can. Do it in your head, okay? It goes way faster. So the square root of 1825, 2.7, 42.